going to find the derivative of this function s of t. S of t is a rational function, 3 over a polynomial. We could use the quotient rule, but since we just have a scalar in the top, since 3 is just a number in the top of the rational function, why don't we rewrite the function? I'm going to reveal. I've chosen to rewrite s of t as 3 times the denominator to the negative 1 power. So I've rewritten, and now I can just use the generalized power rule to find s prime. Let's find s prime. The derivative s prime of t now we have that scalar 3 from the original function. Since this is just a number multiplying the parentheses, I can write down the number. I don't have to use product rule. I'm just using generalized power rule. Now I look at this factor in the original function. It has an exponent of negative 1. I need to bring down the negative 1 and multiply in my derivative. Leave the base alone, t squared minus 4t plus 1. And back from my original function, I subtract 1 from that exponent. Oh, but we can't forget the chain rule. Since this was a function raised to a power in the original, I need to take the derivative with respect to t of this polynomial. The derivative of t squared is 2 times t. The derivative of negative 4t, negative 4. And the derivative of 1 is 0. I need to put parentheses around this little polynomial. This polynomial is the derivative of the original base. Okay, we've applied the chain rule, and we have a derivative. It's not very pretty, but it's a derivative. Why don't we tidy up? Let's multiply the constants in negative 3. Now look over here. I have a factor of 2t minus 4 in my derivative. And this polynomial is raised to the negative 2, so I'm going to drop it down to the denominator. Polynomial t squared minus 4t plus 1 is now raised to the second power in the denominator. Okay, there's our derivative. We notice that the base here in the denominator, t squared minus 4t plus 1, is the same base we had in our original, t squared minus 4t plus 1. And with more practice, we're going to find when we have a rational function like this, the denominator will be squared before we do any simplification of the derivative. Neat. Now a person should be in the habit of checking to see if anything simplifies in their answer. I see that I have a common factor of 2 that I could factor out, leaving me with this linear factor t minus squared inside the parentheses. If this denominator would factor into linear factors, we might do that. But I can't think of any factors of positive 1 that add up to negative 4, so this doesn't simplify. Another trick, it's just something to look for. Positive 2 makes the numerator 0. Does positive 2 make the denominator 0? No. 2 minus 8 plus 1 isn't 0. So I can see that here is my final answer, and it cannot be simplified.